Okay, guys, today I want to look at this worksheet called two-step conversions. These are the hardest types of problems in this unit because it incorporates all the other types of problems we've done in this chapter and it puts them together. So earlier in the chapter, you guys were converting between moles and mass, moles and volume, moles and particles. This involves you converting twice in each problem. That's why they're called two-step problems. So you're going to have to do two of the previous types of problems together in one. It sounds like it's hard, but it's really just multiplying or dividing a couple numbers. So I'm going to do like a third of the problems with you guys right now, just to give you guys an idea of how to do these, and then you guys can try the rest on your own. Okay, so number one, it says how many oxygen molecules are there in 3.36 liters of oxygen gas? So start by writing 3.36 liters O2 in the first block. Now, if you notice on each problem, I don't know if you can see it, I gave you guys like a little road map. It tells you what to do. You're going from volume to moles to molecules. Now, if you guys pull out your mole road map I gave you, it tells you literally exactly what to do each step of the way. But I want you guys to just start figuring it out based on units. So remember, whatever unit is here, liters O2, has to come down here. Now, if you look at the road map I gave you right here, it says I'm converting to moles next. I'm just going to fill in my units and I'll come back and fill in the numbers. So look, that lets these units cancel out. Now the mole oxygen is going to come down here. And the question asks me to figure out how many molecules there are. So molecules of O2 goes there. So now the last thing I have to do is just plug in my two conversion factors and I'm done. If you guys remember, 1 mole of any gas equals 22.4 liters. That's just a conversion factor. It's not something you had to like find. It's just that's always the same. And then 1 mole of any substance always equals the same number of particles, which could be molecules, atoms, or something called formula units. It's always that big number, 6.02 times 10 to the 23rd. Okay, now you pull out your calculator. I'm just going to cancel out that unit. 3.36 times 6.02 times 10 to the 23rd divided by 22.4, and you should get a final answer of 9.03 times 10 to the 22nd molecules O2. Okay, so that's our answer. Okay, let's try number 2. Okay, number 2 is different because this time it asks us to go from molecules to mass. So I'm going to start by writing the number they give us. 2 times 10 to the 23rd molecules of fluorine gas, which is F2. Okay, now I'm just going to use the road map to just put my units up there first. So if that's molecules F2, it also has to go down here. And I have to convert that into moles of fluorine gas, just so this unit and this unit cancel out. Now moles of F2 have to come down here. And the problem asks me to solve for mass, which is grams of F2, which has to go there. And then this unit cancels out. Once again, same thing. All I have left are my two conversion factors I just need to plug in. So remember, 1 mole of any substance always equals 6.02 times 10 to the 23rd molecules of that substance. Okay, now I come over here. 1 mole of fluorine gas equals how many grams of fluorine gas? This one's not a standard conversion factor. This is where I pull up my periodic table. I find fluorine over here. It is 18.998. Let's just call it 19. It's 19 times 2, because there's 2 of them, so 38 grams. Okay, now I just pull up my calculator. 2 times 10 to the 23rd times 38 divided by 6.02 times 10 to the 23rd. I'm going to write it right here because I'm running out of room. Your answer should come out to 12.62 grams of fluorine gas. Okay, so again, they seem like a lot of work, but it's really just 2 mathematical operations. Multiply 2 numbers or divide 2 numbers. But there's going to be 3 total numbers in each problem, disregarding the 1s because those 1s are always going to be there. Okay, give me a second to erase this. Okay, let's try number 3. Okay, this one is again a different type problem. This one it wants us to convert from mass to volume. So it says you have 14 grams of nitrogen, which is N2, at standard temperature pressure, and wants to know how much volume we have. So again, I'm going to fill in my units first. So I'm going from grams of nitrogen. Moles is always going to be the middleman. Moles always in that second block, if you haven't noticed that yet. It's the one right in the middle of your mole roadmap for a reason. Everything goes through the mole. Okay, then moles of nitrogen have to come down here. And the problem asks me to solve for volume, which is liters of N2. Okay, again, this unit and this unit, this unit and this unit cancel out. Now I just stick in my 2 conversion factors and I'm done. Okay, so 1 mole of nitrogen gas weighs how many grams? Pull your periodic table. Nitrogen weighs 14. I have 2 of them, so 14 times 2, let's just call it 28. It might be 28.01 or something like that, but close enough. Okay, then over here, 1 mole of nitrogen gas is how many liters? It's always that same number, 22.4. Okay, so now I just take 14 times 22.4 divided by 28, and you should get 11.2 liters of N2. Okay, let's do one last one. I'm going to skip down to number 5. I'm going to do number 5 because number 4 was the same type of problem as number 2. So if you want to do 4, look right back at number 2. All you got to do is change the molar mass to the molar mass of nitrogen, which we just did, which is 28. It'll be the same as number 2. Okay, number 5 wants us to convert from mass into formula units, which are the same thing as particles. So we're going to use Avogadro's number. So I'm starting with 143 grams of NH4 2S, ammonium sulfide. Okay, and it wants me to convert to formula units. So again, this unit has to come down here, grams of NH4 2S, and I'm going to convert that to moles of NH4 2S. Sorry, I'm going to have to try kind of tiny. My board's not that big. Okay, this unit's going to cancel out. Okay, now this unit, moles of NH4 2S, has to come down here so that this unit cancels out. And I'm trying to solve for formula units. So formula unit of NH4 2S. Okay, last thing, just plug in my 2 numbers and I'm done. Okay, so 1 mole of NH4 2S weighs how much? Pull out your periodic table, add them all up. 2 nitrogens, 4 hydrogens, and 1 sulfur. And I got 68 let's call it 07. Okay, and then lastly over here, 1 mole of NH4 2S is how many formula units? That's that big number, 6.02 times 10 to the 23rd. Okay, so lastly, pull your calculator, 143 times 6.02 times 10 to the 23rd, divided by 68.07. I'm going to write my answer right here. I got 1.26 times 10 to the 24th formula units of NH4 2S. Okay, so all the problems are the same type of problem. I mean, they're all starting in one place and ending in a different place, but you're always doing the same things. The mole is always going to be in the middle. It's always your middleman. You got to figure out what operation to do to get to moles. Am I using molar mass? Am I using that molar volume, the 22.4? Am I using Avogadro's number, 6.2 times 10 to the 23rd? But either way, you go to the mole as the middleman, and then you use mole to convert to your final unit, whatever that is. Use the mole roadmap. It literally tells you exactly what numbers to plug in each block if you learn how to read that mole roadmap. But I want you guys to eventually just learn how to do it without the roadmap. Okay, if you guys have any questions on these, I did about a third of the problems. There's another 2/3 left to do. So please do this on your own. Let me know if you have any questions.